Hello, my students, and welcome to this episode. In this session, we are going to revise vectors. So what is the definition of the vector? The vector is a quantity which has both magnitude and direction. So if we have a vector like AB, if you are talking about line segment AB, so we can say that line segment AB equals 5 centimeters. Or we can say BA equals 5 centimeters. This is the magnitude of this line segment, the length. When it comes to the vector, there is a big difference between saying the vector AB and the vector BA. However, both of them, AB and BA, had the same magnitude, but they are different in the direction. So AB, the vector AB, equals negative BA because they are having two different directions. Let's look now at this diagram. And I have a couple of vectors here. If we looked at the vector CD here, so we say that the point C, okay, to the point D, we moved 2 units in the positive sense here, and 3 units up. So vectors can be notated in many ways. We can say the vector CD, or we can say the vector from C to D, okay? And what is the vector CD? The vector CD, because we moved 2 units here in this positive sense and 3 units up, so the vector CD equals 2 and 3. That is the direction of the vector CD. It's not the length of CD, it's the vector CD or the direction CD. And I'll tell you later how can we find the length of CD. Just to find the 2 coordinates of the point C, which is -4 and 1, and the 2 coordinates of the point D, which is -2 and 4. We can find the length of CD. It's the square root of -4 minus -2 to the power of 2, y minus y to the power of 2, plus x minus x to the power of 2. So what's x here? It's 4. So we can say 4 minus 1 to the power of 2 plus -2 minus -4 to the power of 2. That leads to get the square root of 4 minus 1, 3 to the power of 2, it's 9, plus -2, -4, which is 4, 4 plus 2 is 2, to the power of 2 is 4, so the square root of 13. That is the length of CD. What about the vector here? If we looked at this vector here, what is the vector here? This vector is C. Look at the direction of C. We moved from this point here to this point. So we moved in the positive sense across x 1 unit, and we moved down 2. So this vector is 1 and -2. 1 and -2. The vector C is 1 and -2. What about the vector D? The vector D, we moved from this point to this point here. This is the line segment, the directed line segment. And we moved 3 units in the negative sense of x, 3 units here. So it's -3. And we moved down 2 units, so it's -2. The vector D is -3 and -2. And what is the definition of the unit vector? Look here at the vector I on the graph here. So what are the coordinates of this point here? It's 1 and 0. So what is the vector I? The vector I is called unit vector. The vector I is called the unit vector. And the vector I is 1 and 0. And what is the vector J? The vector J in the y direction, and the vector J is 0 and 1. Okay, we can write any vector by using I and J. How is that? So let's analyze it. The vector CD is negative. The vector CD is 2 and 3. The vector CD is 2 and 3. So imagine that I have a vector CD. It's 2 and 3. Okay. We can write this vector as 2 multiplied by the unit vector. Okay. In the direction I, the direction of X, which is 1 and 0. Okay. Plus 3 multiplied by 0 and 1. This is I, the unit vector I, and here the unit vector J. So if we multiply them, you will end up with 2 times 1 is 2, and 2 times 0. So here it's 2 and 0. Plus 3 times 0 is 0, and 3 times 1 is 3. When adding them, you will add 2 plus 0, so it's 2. And 0 plus 3, it's 3. So we can write CD, the vector CD, instead of 2 and 3, we can say 2I. What is I? I is 1 and 0. That's I. And plus 3 multiplied by J. What is J? Is 0 and 1. So the vector CD can be written in many forms. The first form, we can write CD as 2 and 3. This is the column way, and we can use the unit vectors 2I plus 3J. This is the vector CD 2I plus 3J. What about the unit vectors in the 3 dimensions? So in this case, we'll write I as 1, 0, and 0 because we moved 1 in X in the direction of X axis. So it's 1. And in Y axis and Z axis, 0 and 0. What about J? J is the unit vector in the Y direction. So J is going to be written as 0, 1, and 0. What about K? K is the unit vector in that direction. We moved 1 unit only on that direction, and X-axis, Y-axis are zeros. Let's have a look at this cuboid here. This point is defined as 3, 5, and 1, and this point is defined as 7, 8, and 3. What is the vector AB? The vector AB, because we moved from 3 here to 7 on X-axis, so we moved 4 units on X-axis. Okay, and if we looked at Y here is 5 and Y here is 8. We moved from 5 to 8, so we moved 3 units on Y axis. And if we looked at 1 on Z, 1 and 3, so we moved 2 units on Z axis. So what is the vector AB? We moved 4 units in X-axis. So it's 4J. J represents X-axis. Plus 3 units from 5 to 8. So plus 3J and plus 2K. So we can write the vector AB as 4I plus 3J plus 2K. Or we can write it using the column way. The column way is 4, 3, and 2. That's it. Let's go to the position vector. And what is the definition of the position vector? The position vector is that vector which starts at the origin point. So if we looked at C here, the vector C. The vector C started at the origin point and ends in C. So we can write it as OC, or we can write it as a shortcut as C, the vector C. So what is the vector C here? The vector C, we moved from the origin point, how many units on X-axis? 1, 2, 3, and we moved up 2 units. So the vector C is 3 and 2, or we can write it by using the definition of the unit vector, which is 3I plus 2J. They have the same meaning. And if we compared the vector C to the vector AB, you will find that they are the same. Why is that? Because the vector AB, okay, if we moved from A to B, we moved how many units? We moved 3 units in the positive sense here on x-axis, and we moved up 2 units. So the vector AB is the same as 3 and 2, or we can write it 3i plus 2j. So we can say that the vector C and the vector AB, they are the same. Do you know why? Because they have the same direction and have the same magnitude. They have the same direction and they have the same magnitude, okay? And we can draw a lot of equivalent vectors. If we took this point, for instance, and we moved 3 units here in the positive sense and 2 units up, you will get the same vector, okay? And if we moved from this point here, 3 units in the positive sense and 2 units up, you will get the same vector. So we can draw an infinite numbers of equivalent vectors here. But the vector C is called position vector. The vector C is called position vector. Okay. Why position? We call it position vector. We call it position vector because the position vector always start at the origin point. If we looked at this key point here, and as you know that I is 1, the unit vector I is 1, 0, and 0, and the unit vector J is 0, 1, and 0, and the unit vector K is 0, 0, and 1. What is the position vector of B? If we looked at B here, we have 4, 3, and 2. So we write it as OB. Do you know? OB is the same as the position vector B. But B is a shortcut in writing. Instead of writing OB, we write it as B. And here we moved 4 units on x-axis, as you see, and 3 units on y-axis, and 2 units up here. So what is the position vector here, OB? It's 4i plus 3j plus 2k. So we say that the two vectors are the same if they have the same direction, and the same magnitude. So here the two vectors here I'm drawing, they are the same, okay? Because they have the same length and they have the same direction. All of them are equal. They are equivalent vectors because they have the same direction and they have the same magnitude. They have the same direction and they have the same magnitude. So they are equivalent vectors. And if I have a vector like AB, this vector AB, we couldn't say that the vector AB is the same as the vector BA because they have two different directions. But we can write AB vector equals negative BA vector. That means they have the same magnitude, but they are different in the direction. They are not the same. And if I'm going to draw a parallelogram here, like this one, the parallelogram is A, B, C, D. The vector AB, or the directed line segment AB, is the same as the vectors DC because they have the same length, or they have the same magnitude, and they have the same direction. What about the vector DC? The vector, DA here, the vector DA. We moved from D to A. So the vector DA is the same as the vector, don't say BC, you write CB. Do you know why? Because they have the same direction and they have the same magnitude. Now let's go to the XY coordinate plane just to show you something very, very important. Here I have the vector AB. Okay, the vector AB is equals what? We have here 1, 2 units. We move the 2 units in the positive sense across x-axis, and we rise it 3 units up. So the vector AB is 2 and 3. Okay. We can find the position vector of AB by using this way, just to move from this point here, the origin point, 2 units here to the right and 3 units here up. This is the position vector, which is equivalent to AB. This is a way to find the position vector by finding the distance from B to A. Okay. Just find how many units you moved across X and how many units you moved up across Y. This is a way to find the position vector. And the second way to find it, AB, we can find it by subtracting B minus A. What is that? So if you wrote B, B is defined as -1 and 4 minus A. What is A? A is -3 and 1. Subtract -1 minus -3 is going to be what? 2. And -4 negative minus 1, it will be 3. This is a way to find the position vector. So here we have the vector AB, and here we have the vector OC. OC, we can write it as a shortcut and write it as C. And the vector C is defined as 2 and 3. Okay. ايه يا باشا؟ هخلص وما نمشي ولا ايه؟ انا معايا 10 دقايق اخلص اقل حاجه كده على ماشي. Once again, okay, if we have x and y, okay, x and y is the Cartesian coordinates. I want to get the polar coordinates. So to get the polar coordinates, because x and y is a point in xy coordinate plane. This is the point x and y here. How can we get the polar coordinates? So we can get the polar coordinates if we manage to find the length here r. So how can we find r? We can find r if we found the square root of x squared plus y squared, okay? And how can we find the angle theta? We can find the angle theta, you know, tan theta here equals opposite over adjacent equals y over x. Let's take some examples. Convert the Cartesian coordinates to polar coordinates. Number 1, Here I have the point P is 12 and 5. How can we convert to Cartesian coordinates? So the length are equal the square root of 12 squared plus 5 squared. Okay, it's 144 plus 25, 169. So R equals what? 13. This is the length. And how can we get the angle theta? You know, the angle theta equals, you will find the tan theta. And tan theta equals what? Y over X. So tan theta equals 5 over 12. And by using the calculator, shift tan 5 over 12, it will be 22.6. The angle is 22.6 degrees. So the angle or the polar coordinates 13 and 22.6. That's it. What about the next point? The next point is -4 and -3. So we will find R, the square root of -3 to the power, -4 to the power of 2 plus -3 to the power of 2, which is 5. When it comes to angle, we have here -4 and -3, and -4 and -3 lies in the third quadrant. And the third quadrant, after finding the acute angle, it's 180 plus theta. So you will hit on the calculator, shift tan, okay, y over x -3 over 4. So shift tan 3 over 4. Tan theta equals -3 over -4, which is 3 over 4. Okay, you will find the angle. The angle equals 36.8. And you will add 180 plus 36.869. This is the angle. So what is the polar coordinates? It's 5 here and 216.9. That's it. How can we convert from a polar system to Cartesian coordinates? We have here R and we have here the angle. The angle is 2 pi over 3. You know 2 pi over 3 and the radian measure, we can write it in degree measure. It's 2 times 180 over 3. It's 1 here and 6, so the angle is 120. So to get x, just to follow this rule, it's 5, okay, cosine 120. And to get y, it's 5 sine 120. That's it. So you will get the angle. And to get x, 5 cosine 120, and to get y, 5 sine 120. So 5 times, by using the calculator, cosine 120 equals -2.5. And y is defined as 5 times sine 120 equals 4.3. That's it. I hope you enjoyed this session. See you in the coming episodes.